Okay, so this is the one we need to know and be able to use. If we took that one more step and took another time derivative, we will get the r double dot. And I think I'm missing some vector signs. Not pretty good. R double dot would be equal to the velocity in the radial direction dotted, or the acceleration in the radial direction. Okay, what we get is the acceleration is equal to, and this is the one I'm going to leave up to y'all, r double dot minus r theta dot squared plus r theta double dot plus 2r dot theta dot, and that's in the unit theta direction. But I'm going to sit here and make sense of this with you. What does this term mean? Well, if we had some path and some vector and it extended out further, then that would be some acceleration in the unit r direction. It extended with some acceleration. Now what about this one? If we held a distance r, so think about some circular path maybe, same r, and we went through it with some v squared, or theta dot squared, right? How fast this angle is sweeping through, not v squared, that's a bad term. We will get a component that points inwards, like our normal component almost, right? Except it's in the radial direction when we're working with these components, and we get the minus sign because it's pointed inwards. Okay, the unit theta direction is how fast something, this is our position vector r, here's our path, it's how fast something is sweeping in the perpendicular direction to r. So if we held r constant for this one and had it accelerating in the theta direction, then we're going to get some acceleration, r theta double dot right there. So that one makes, all three of those make sense to me so far. This one makes a little less sense. If we have so we're looking at 2r dot theta dot. Here's our path that we've been looking at. Here's some vector r. Imagine it having a little bit of a velocity in this direction and a little bit of a velocity in this direction. That means it changed directions. And we're looking at infinitesimal amounts, and we can say that it had some component or unit direction in the unit theta direction. So 2 times the velocity, or r dot, times theta dot would give you something directly along that path, right? But we can still say that the component instantaneously is in that theta direction. Alright, I recommend taking a look at the book. There's lots of diagrams. Go ahead and read through it. It's not too long, and if you want to work through some more derivation, you can. But real quick, we have 2 types of problems now. One would be if we have some like polar coordinate given, and this is expressed as a function of time. So what does that mean? We could have r as a function of time and theta as a function of time. Now what do we do with those? Well, we do what we did with x and y. We take time derivatives, and we might have to use the chain rule to get theta dot and r dot is a function of time, and r double dot is a function of time, and theta double dot is a function of time. So those are all time derivatives. If it's not parametric in t, this is parametric in t right here. If it's not parametric in t, that's our other type of problem. So this would be r is equal to a function of theta. This we're definitely going to have to use the chain rule that will introduce time into the problem, the one I put the tutorial up for. So we could have some path given. We've seen like x squared over 20 before, I think the balloon problem maybe. And well, we could have r as a function of theta squared over 20, right? It could be something like that. And to find r dot, r double dot, theta dot, and theta double dot, you'll probably have to use the chain rule. Or you will, for sure. When I said chain rule up here, this just meant we could have a composite function. You're definitely gonna probably have to use the product rule. Just get familiar with all your calculus and your easy functions so you can just crank those answers out. Quick notes. We can say that the velocity in the r direction and the velocity in the theta direction are perpendicular, and the acceleration in the r direction and the acceleration in the theta direction are perpendicular. So all of this was based on that fact, and as a consequence we can find the magnitudes of each by taking the squares of the components added up and square rooting. So, alright, that's it. Thank you.